did go through an email, so you should have it, okay? Basically, what I'm going to do is start Chapter 2 today, okay? Chapter 2, I mean, the first section here is actually not too bad. It might be more of a review for most people, but if it's not, that's okay. Yeah, I'm not going to go super fast through this. But basically in Chapter 2, this section, we're going to look at the Cartesian plane. That's what we're going to do in this section here. We're going to see what it is, and you'll actually see, just like the real numbers, is a very good, what's the word? It's a way of visually representing the collection of real numbers, the number line that is. The Cartesian plane is a very good way of representing the collection of ordered pairs of real numbers. And it's actually very useful. You will have to deal with that collection of all ordered pairs of real numbers. Whether you know it or not, you do have to deal with that collection, excuse me. So the Cartesian plane is actually very useful. In fact, we're going to see the distance formula for 2 points in the Cartesian plane. In other words, we're going to come up with not come up with, I guess, but we're going to see the formula for calculating distance between 2 points in the Cartesian plane. We'll also see what's called the midpoint formula. With the midpoint formula, okay, there, if you have 2 different points, okay, you could connect them by a line segment. The midpoint formula will give us the midpoint of that line segment. You'll see what I mean when we actually see that formula, okay? All right, it's nice as you don't have to memorize these formulas. All right, so what is the Cartesian plane? Well, if you take 2 copies of the number line, one of them is horizontal, the other one is vertical, okay? And basically when they intersect each other like this, okay, one is vertical, the other is horizontal, you have essentially the Cartesian plane. The horizontal line is the x-axis. The vertical line here, we call that the y-axis. Okay, that point of intersection is what we call the origin, where that point of intersection is. And really that point is going to be 0 on both of these lines. Okay, somewhere you have to label 0, right? Well, that's going to be 0 for both lines. Remember, these are both copies of the number line. All right. Okay. And here, this is what happened. And here, this is just another representation of it. Remember, with the number lines, of course, you could just label it with numbers, right? We've done that before. I mean, here I'm labeling it with a half as well as integers, right? You go 1 unit to the left, you hit 1. Here we can go half a unit instead. We get a half. You go another unit to the right, you get 2. Half a unit to the right, you get 1.5, and so on and so forth. We're labeling the number lines, the horizontal number line here with numbers, and we do the same thing for vertical. Remember how to the right you go, to the right you're positive, to the left the numbers are negative. For the vertical axis though, if you go up, you get the positive numbers. So if you go, in this case, instead of going right or left, you're going up, you get positive numbers. Going down, you get negative numbers. And again, 0 here, that's 0 for both number lines. And this is, again, the Cartesian plane. Now, this is a visual representation of ordered pairs of real numbers. And I figured it'd be good to put this picture in just to help illustrate as opposed to this one. Okay, so again, the notes I just emailed to you. Again, I am sorry that I did not email it to you before class. I apologize. Okay, so again, this is a visual representation for ordered pairs A, B. The idea basically is the first number here, the A, in other words, this comes from the x-axis, the horizontal axis. That's where this comes from. The second number, B, comes from the y-axis. First number, the A, from the x-axis. The second number, B, from the y-axis. And also, the origin, again, that's where they intersect, right? That's just the point 0, 0. Okay? That's just 0, 0. Basically, the idea is this. Every point in the Cartesian plane will correspond uniquely to an ordered pair of real numbers. Remember how with the number line, every point on that line, right? Every mark, I guess, so to say, corresponds to a unique real number. With the Cartesian plane, every point corresponds to a unique ordered pair of real numbers, and the other way around as well. So every ordered pair corresponds to a unique point in the plane, which is tied in now to how we plot these points. How do you actually plot these ordered pairs? Well, for the point AB, for the ordered pair AB, right, you have to locate A, which is on the x-axis, excuse me. You have to locate A on the x-axis, okay? So let's say A was over here. It doesn't have to be to the right over here. You know, it could be to the left. Then you're either going to go up or down from A. You know, vertically, that is. You're going to go up if B is positive. You're going to go up B units, as in the picture. You would go up B units. You would go down, though, if B were negative. You would go down the absolute value of B units. Remember, absolute value is distance, right? Distance along the number line, that is. Okay, so you go up or down, B units, basically. Again, you locate A on the x-axis, right? You're going to go up or down B units if B is positive or negative. I mean, if we were to zoom in on this point, this is what would be happening, right? We locate A on the x-axis, and here B is positive, so we're going to move up B units. And that's how we get to the point AB. That's how we get to it. I was going to say this later, but I'll say it now, I guess. I'll say it now. The A, which comes from the x-axis, right? Well, you can hopefully see from here, the first number here, A, that tells you how far you are horizontally from the origin. You know, so you start at the origin, right? The A, the first number, tells you how far you are horizontally. See? You go over here to A, you're this distance here from the origin, right? This horizontal distance. If A were negative, the only difference is you would be to the left. That's what the first number tells you, the A, how far you are horizontally. You know, from the y-axis, I should say. For B, that's the height above, or relative to, that is, the x-axis. You know, B units up, right? That's how high up you are. If B were negative, the only difference is you would be down here. Your vertical distance, your height, from the x-axis. I mean, that will come up again today, so I hope that made sense what I said. All right, well, let's make this easier to understand by looking at some examples. So let's say, for instance, that we wanted to plot some points. Let's say we wanted to plot the point 1, 2. I mean, it's up here already, but how would we plot it? Well, you start at the origin, right? You go 1 unit to the right. That is, excuse me, let me say it again. We locate 1 on the x-axis. Okay, 1 is on the x-axis right here. But now, since 2 is positive, right, the second number is 2, we go up 2 units, and we are at the point 1, 2. 1, 2, okay? Again, we're 1 unit. I mean, we are 1 unit to the right, right? 1 is the x coordinate, the first number that is. That's how far we are horizontally. And our height, that's what 2 is, right? We're 2 units up. What about this point, 2, 1? This is a little bit different. What do we do? Well, again, we're at the origin. We're going to go 2 units to the right. That is, we're going to locate 2 on the x-axis over here. Okay, we're going to locate 2, as you can see. Then we go up 1 unit. Again, we're going up because the 1 is positive. Right? The first number here tells you how far you are horizontally. Right? We locate 2 on the x-axis, yeah? Which really is the same as saying 2 units from 0. Then you go 1 unit up. Okay. What about this point here? Well, here we have to get to -3 on the x-axis. We have to locate it. Okay, well, it's going to be 3 units to the left. 3 units to the left.